Okay, one part. Okay. Maybe some of the students they join online class today. So we just start the class. We have to finish the syllabus no matter how. But I think we can, if we are managed to finish the syllabus in normal pace. Okay, so in the last class, okay, we have learned the unit binormal vector. Okay, binormal vector is perpendicular to both P and N. Okay, because B is obtained through the cross product of P and N. So when T cross N, we get a B. So that means B is perpendicular to the T and also N. Okay, so these are the derivation to get the formula of the binormal vector. Okay. So this one, if you have the T and N, you can get the B by finding the cross product of P and N. Okay. Other than that, we can have this formula. Okay, this is an alternate formula to get the binormal vector. Okay, meaning that you just need to find R prime, R double prime, and the cross product, and also the magnitude. So that's it. If you use this, we can skip the P and N. Okay. Okay, so between this formula T cross N, get a B, or the cross product of R prime and R double prime. So here, actually, you can see that under different situations, we can choose different formulas. Okay. If the question it contains the sine cos, okay, the simpler one, then you can choose the T cross N. There's no issue because you can find the T and N. Okay, and the magnitude of R prime, magnitude of T prime, it doesn't give you much problem there. Okay, if your RT is cos and sine function. But if your RT it contains polynomial, one function, or anything other than sine and cos, then I would suggest you to use this. Okay, because this one you just need to find for the R prime and R double prime. Okay. Okay. Okay, from the T, N, and also B, okay, actually this forms a frame called Frenet serrate frame. Okay, this is a frame, and it has sets of formulas. Okay, so these are the formulas. Okay, but we are not paying much attention on these formulas. Okay, and how to get this? This one we have already discussed on the last class. Okay, T N cross B. Okay, N cross B, that means positive T. B cross T, B cross T, that means positive N. And T cross N, you get a B. Okay, now with the three axes, okay, with the three axes which are perpendicular to each other, okay, means that you can have a plane. You can have a plane that span the T and N. Okay, meaning that your T and N falls or lines on a plane, and that plane is called oscillating plane. Okay, these two axes falls on the plane, and that plane is called oscillating plane. Okay. If T and B, okay, for T and B, that lies on the plane, okay, that plane is named as rectifying plane. And one more, this is called normal plane, the one between N, not between. The plane which the plane where N and B lines on. Because the plane can be a big plane, not limited to this. Okay? It can be a big plane. As long as the N and B lines on the plane, that plane is called normal plane. Okay, so here we will focus on this oscillating plane. Okay, we focus on the plane where T and N lines on. Okay, this one. Along a space curve. Okay, this is a space curve. Okay, there are finite serrate frames on the evenly spaced point. Evenly spaced means the space in between 2 points are the same. Okay, the distance are the same. That is called evenly spaced point. Okay, so evenly spaced points on the curve to show the direction of a moving particle. Okay, when a particle moves, you have to imagine that at every single point there is a finite serrate frame. Okay, I just go through this sentence first. Later I will show you. Okay. Okay. So this frame, it can show us the direction of the moving particle. Okay. Tangent vector T. T points in the moving direction. T will always point to the moving direction. So you see this one, N is in blue, T is in red, B is in green. So the one in red, okay, this one in red. Red. That means the particle moves in this direction. Okay. You see the red arrow, it points into this direction. Okay, into this. At every single point, it points in this direction. So we know that the particle moves in this direction. Okay. And the normal vector, it points to the inner side of the curve. Okay, inner side of the curve. Okay, now imagine a boy is riding a roller coaster, and the boy is sitting on the oscillating plane. Okay, oscillating plane is the plane that contains the T and N. Okay, the boy is sitting on an oscillating plane, and the boy is facing to the moving direction. Okay, facing to the moving direction T. So when the roller coaster turns to the left-hand side, the normal vector is pointing 90 degrees to his left. Okay, and his head is pointing upwards. The boy sitting on the plane, he just moved into he's facing the direction of motion. Once it's moved, his head pointing upwards, and the normal plane is pointing to his left, 90 degrees. Okay, 90 degrees. But for the case it turns to the right, okay, when it turns to the right, his head is pointing downwards now. Okay, pointing downwards, where his head is still pointing to his left. That means his left hand, okay, it just maintains. Okay, when it turns to the left, it's in this direction. Turn to the right, that means the head is pointing downwards. Okay, this one I show you by using this. Okay, so let's say now I have a plan. Okay, this is a plan. This is the tangent plan. This is the normal plan. So meaning that this plan is called oscillating plan. Okay, oscillating plan. So this is the binormal vector. This is the T. This is the N. So the boy is sitting on this plan facing to that direction. Let's say it moves in this direction. Okay, so when it moves to the left, okay, when it turns to the left, it is in this. Okay, his head pointing upwards. But when it moves to the right, it will be something like this. So whether it turns like this or it turns like this when it moves to the right hand side, when it turns right. Okay, so to decide whether it moves, turn in this way or this way, that one will decide by the torsion later. Okay, you will learn another word, torsion. Okay, so at this moment, what you need to know is this is the oscillating plan where the particle moves in this tangent vector in this direction. And the normal vector, it will always point to this direction. Okay. When it turns to the left, it is in this form. When it turns to the right, it will be downwards. Okay. When it turns to the right, it will be downwards. It can be turned like this or this. It depends on the side of the torsion. Okay, now we look at the slides again. Okay, so you see that's why, okay, starting, okay, it moves from this point, go to this point. So the normal vector it points to the left. On the left. I think the color is the reverse. Point to the left. Oh yeah. Okay, this one. Okay, this forms 90 degrees. I think the color is wrong. This one should be normal vector. This one should be binormal vector. You see. And it's blue. And it's blue. This one should be blue. This one should be green. Okay, it points upwards. It's wrong here. Okay, this one should be green. Okay, it points to the left. Okay, this one points up. Okay, when it turns left, okay, B pointing up. B. Should be like this. Should be like this. Tangent, normal vector, and binormal. Binormal is this one. Done. Can't see it clearly from this. Okay, sure. Okay, as long as you understand when it moves, okay, to the left, the binomial vector is pointing upwards. Okay. And when it turns to the right, the binomial pointing to downward. Okay. It can turn on the oscillating plane, it can turn either to the direction of n or opposite the n. That one depends on the torsion. Okay, now we look at the formula, the example. Okay, example for the unit binomial vector. Okay, so given R, compute the binomial vector at t equals to 5. Okay, so this one is use the first formula. Okay, t cross n. So it finds for t, finds for n, then t cross n. So when you do the cross product, okay, look at this. Your t has a constant. Okay, your t has a constant. So when we do the cross product, actually you can leave it outside. Okay, you don't have to multiply into every single component. Okay, just put it outside. Okay, and n, this is your n. Okay, just find the cross product of this. So if you for n, if your n has a constant similar like this, then that constant will be multiplied with this constant to get a new constant. Then you just find the cross product between that two factors. Okay, so this is the b. And lastly, substitute the pi, because according to the question, we want the binomial vector and t equals to pi. So just substitute t by pi. Okay, this one pi, this one is also pi, pi. Then get the final answer. Okay. Okay, another example. Okay, find the binomial vector at t equals to 0. Okay, this one is similar. You find for the r prime, magnitude of r prime, find for the t. Okay, you got a constant for t. Okay, when you find for the t prime, this one, because this is just a constant, so just leave it, you just find the derivative for the vectors. Okay, magnitude of t prime. Okay, leave it. Find for the magnitude of this. Okay, then you will get a value. Okay, then your n, according to the formula, you need t prime over magnitude of t prime. Okay, this is your t prime divided by this, you get this. Okay, and finally t cross n. But this one, you can either find the cross product, then you substitute t by 0, or you substitute 0 into the t and n, then you find for the cross product. You get the same result. Okay, so see, we can just leave it. Okay, we can just leave the constant outside. Okay, and find the cross product of this. Okay. So now I want you to try. Okay, trying to solve this 1, 2, 3. For question number 1 and 2, you can use the either one. Okay, either one formula. But for number 3, you have to use the second formula. If you want to use the first formula, actually there is no issue. You will get the same result. It's just that the working will be complex. Okay, for number 3. Okay, now start from number 1. Okay. Okay, which formula you want to use? You want to use the first one or the second one? It's up to you. Which one? The first one is T cross N. The second one is the cross product, the R prime and R double prime. Find it for the cross product. For the first question, I use the first formula. The second one, I use the second formula. This R prime or R prime it E prime magnitude of E prime and then only point for B is E cross N. Balance sign for right-handed? For your T, you can just leave the 1 over the sign outside. Okay, because we have to differentiate this one by trying to so leave this outside. Just differentiate. This is just the constant. This differentiate this T for this one. The 1/5 divided by 4/5, the this one's 4 cos to t 0 divided by 4/5. Okay, so the sub 5 we can cancel out the sub 5, and the 4 can be cancelled out with this 4. So you get negative sine 2t, negative cos 2t, and 0. And lastly, find for the b, okay, t from n. The t cos 2t, negative 2 sine 2t, and 1 cross with n. Sine 2t, negative cos 2t, and 0. Okay, to get the component function of I, okay, cover the first line, AB minus BC. Okay, cover the first line, AB minus BC. So you get a positive cos 2t for I. Then minus the component function for J. You cover the second line, AB minus BC. So you get a positive sine 2t. So the last function after the last line, AB minus BC. AB negative 2 cos squared. minus BC negative is AB minus, so minus 2 sine squared 2t. This is okay. So when you simplify, you get a plus 50, negative sine 50, and the last one, factorize negative 2, you get negative 2 times 1. Okay, any questions? Okay, any questions for number 1? Okay, number 2. Okay, number 2, you can choose either to use this formula or another formula is R prime cross R double prime divided by the magnitude. This is another formula. Okay, you can try the second formula. Okay, let's try second formula number 2. I'm using the second formula of binomial vector to solve question number 2. Anyone else? Okay, the magnitude of this first product is just square every single component function. From here you get 90, so 90. Okay, so 90 is actually 3. That's how you can write that. Okay. 9 times 10. 9 times 10 means 3. It's 9 times 3. So 9 times 10. So this is 3. 3 times 10. Okay. Then we can find for the B now. B is the cross product divided by its magnitude. So we can this one -9 3 cos t -3 sin t divided by 3 sec 10. Divided by 3 and -3 no more 3 cos t -sin t. Okay. Okay, number three, you can use the same formula, find for the cross product of R prime and R prime. Okay. Any questions? Okay, formula, because appendix of the final exam has already been given. Only the formula for the numerical differentiation and numerical integration are given. I mean, all these formulas are not given. Okay, so you now have to find for T, N, and also B. T, N, B. Okay, can we proceed to the next subtopic? Any more questions for binomial vector? If no question, I will move to the last one, torsion. Okay, torsion. Torsion, it measures how much is the curve twisted out from a planar form. Okay, this is what I mentioned just now. When it turns, when the oscillating plane turns, flip. You would say flip. Okay, when the oscillating plane flip, okay, flip either 90 degree or 45 degree, okay, or any degree. Okay, it will affect the torsion because the torsion will be different for every degree of the flip from the oscillating plane. So torsion measures how much is the oscillating plane rotates around the tangent vector. Okay, see, this is the tangent vector. Okay, so if this plane it rotates around this, rotates, meaning that it's one. This is called rotate. Okay, when the oscillating plane it rotates, okay, the torsion value will be different, and in different direction, it will have different signs. Okay, the different signs. So the torsion is determined both in magnitude and also the sign. Okay, so the higher is the torsion magnitude, the more is the deviation of the curve. Okay. So when the oscillating plane it rotates more, that means the torsion has a higher value. Okay. So this one, torsion, it measures the non-planarity. Okay, non-planarity. What is curvature measures? What curvature measures? Do you still remember? Curvature measures non-linearity. Non-linearity curvature. And this torsion, it measures non-planarity. Okay, what is the difference between the non-linearity and non-planarity? Non-linearity, that means it is non-linear. Linear, that means it's a straight line. Non-linear, it is not a straight line. So when you have a curve which is not in straight line, the value of curvature is not 0. The curvature for a straight line, it will always be 0 because there is no curve. The curvature measures the curvature. Okay, how is the curve? Okay, how is the linearity, non-linearity? Okay, non-linearity. And this torsion, it measures the non-planarity. Okay, planarity means everything lines on the plane. That is planar. When it comes to the non-planarity, that means the oscillating plane is flipped. Okay, either a little bit or a lot. That is non-planar. Okay. So when the oscillating plane, okay, when the oscillating plane is parallel to the xy plane, the horizontal plane. Okay, when this is parallel to the horizontal plane, then the planarity is 0. It is planar. Okay. So a curve with 0 torsion lies in the plane. Remember this one. A curve with 0 torsion, it must lies in the plane. Okay, and it is known as planar curve. Okay, so a curve that lies on the plane, can it be non-zero for curvature? Is it possible? A curve that lies in the plane, is it possible for the curvature to be non-zero? Yes or no? Yes, it is possible. Remember this? 0 torsions means the curve lies in the plane. The curve lies in the plane. What if there is a circle on this plane? A circle lies in the plane. The circle, the curvature is not 0, right? A circle, the curvature has a constant value because at every single point on the curve, okay, of the circle, it has a same value, no matter which point it is, because it is a circle. So at every single point of the circle, the curvature is the same. But when the circle lies in the plane, the curvature is still the same, right? It still has the value. It depends on how big, how small is the circle. It still has the curvature value, but when it lies in the plane, torsion is 0. Okay, no matter what curve, the curve in the S shape, 0 or linear, as long as it lies in the plane, torsion is 0. It doesn't affect the curvature. The curvature means, I would say, the non-linearity. How non-linearity is the curve? Okay, linear is 0, and sorry, linear is straight line. Okay, non-linearity. So torsion for non-planarity and the curvature for non-linearity. Okay, for non-planar curve. Okay, this one. This is a planar. Okay, planar plane. Okay, in case one, this is case one. The osculating plane is parallel to XY plane. Okay, so now we can say that our XY plane is actually on parallel to the floor. Okay, parallel, our XY plane parallel to the floor. So if your oscillating plane is parallel to the floor, that means torsion is 0. But when you flip a little bit, this is no longer parallel to the floor, right? So torsion is not 0 anymore. Okay, and what is the sign? It depends on how it flips. What is the direction of the flip? Okay, so in case 2, you see this one, when this plane is flipped to the right hand side. Okay, this one, this is the moving direction. This is normal vector. So when it moves to the opposite direction of the normal vector, you get a positive torsion. But if, this one to this one, when it moves to the same direction to the normal vector, this one is flipped to the direction of this end. That means your torsion is negative. Okay, so now you have some idea about the torsion and curvature. These are the derivation of formula. Okay, this is just derivation of formula. What I want to emphasize is this is the formula where we can use to get the torsion. This one. Okay, this formula is the same, similar to the binormal vector. Okay, binormal vector just now. Okay, it's just that you have the dot R triple prime, and this one is square. Okay. Okay, so we will use this formula for the torsion. Okay, this one, some examples of this. The relationship, okay, not the relationship, the shape of the curve and how is the curve, whether lines on the plane or not. Okay, it's all depends on the curvature and torsion. Okay, so now when curvature is 0, okay, you have to understand what it means by curvature is 0. That means no curvature. It's a straight line, right? When curvature is 0, you have a straight line. And when torsion is 0, that means that straight line lies in a plane. Okay, the straight line lies in a plane. Okay, for the second case, curvature is a constant. Okay, you have to remember this one. There is only one case where your curvature is a constant. That means you have a circle. There is no any curve that you can have a constant curvature at every point, right? Only circle can give you the same curvature at every single point on the curve. So when this curvature is a constant, okay, a positive constant, then, and at the same time, the torsion is 0. That means you have a circle that lies in the plane. Okay, in the past year, if you review, okay, the question of past year, I think there is one question asking about what is, I can't remember which one. What do you have when curvature is 0 and torsion is 0, something like that? Or curvature is constant and torsion is 0. Then you have to give an answer. It shows a circle in that lies in the plane. Okay, because you have to understand what these two means. Okay. Next case, curvature is constant, a positive constant. Okay, and the torsion is also a constant. Okay, constant positive value. Okay, constant positive value. So it means you have this right-handed screw helix. Right-handed, that means you use the right hand, and your fingers points in this direction. Okay, your 4 fingers points in this direction, and your thumbs points up. So it will go up. It will turn and go up. So you just look at your thumb in this direction. So that means it goes up in this direction. Okay, maybe those who attend the online class. Okay, this one right hand in this direction, and it goes up. This is right hand, okay, right hand screw helix. So the particle, it will move in this direction and it goes up. Okay, and the constant, this one, the constant torsion means the distance between two circles is always the same. It's always the same. This one, the distance between these two, the distance between these two, okay, and so on, because you have a constant. Okay, the other case, when you have a negative, okay, negative value, that means you have a left-handed screw helix. Okay, left-handed, you look at the direction of your forefingers. Okay, it is all in this direction, and your thumbs pointing upward. So you can imagine the particle, it moves in this direction and it goes up. Okay. Okay, now the last one, okay, this one, curvature is still a positive constant, so we can expect to have a circle. Okay, and the torsion is positive. You see the difference between this one, this is positive, this is also positive. But the difference between this one and this one is, this is a constant. Torsion is always the same. But this one, torsion may be different. So when torsion is no longer a constant, you see the distance between two circles. This is smaller. This one, the distance between two is larger. Okay, because the rotation is different. Okay, so you have a larger torsion. This one you have a smaller torsion. Okay, and this is the example on how to find for the torsion. Since this is the formula, then you have to find for R prime, R double prime, R triple prime, then find for the cross product and the magnitude of the cross product. Then you put everything into the formula. Okay, so you see, find for the R prime, R double prime, R triple prime. Then find for the cross product, the magnitude of the cross product. Then you can start to find for your portion. Okay, so this is dot product. Okay, dot product, it gives you only scalar. So no, you don't have any vector anymore. Okay, portion, when you see this dot product, vector, dot vector, you get a scalar. Okay, this is another example. Okay, similar example. Okay, so you have so your portion may be negative, may be positive. It depends. It depends on the part. Okay, now let's try this exercise. Prime, R double prime, the complication. I think the complication shouldn't be a problem for you. It's just that you have to understand what is the curvature and what is the Product, the first multiply the first plus the second multiply the second plus the third multiply the third. Okay, no more factor. Okay, number 2 and number 3 are similar to this question number 1. We have done question number 1, proceed to number 2 and number 3. Okay, for the cross product, actually you can use the IJK thing. Then you put the 1, 3 cos t, negative 3 sin t. 0, negative 3 sin t, negative 3 cos t. Okay, you can find for this one. Okay. So either you use this way or you use this way. You get the same answer. You get this, power the first AD minus BC. So AD, you get a negative 9 cos squared T minus, okay, this one you give positive, minus 9 sin squared T, which is for I. Okay. For J, power the second line, AD minus BC 0. J, and then the last one K, cover the last line, AB minus BC is 0. Okay, so you have the negative 9, 3 on T, negative 3 sin T. Okay, for the first product. That's number 2. Okay, number 3, I leave it to you to have a try on your own. Since number 3 is similar to number 1. Okay. Now I send a link to the WhatsApp group. Okay, done. Number 2. Okay, number 3, you try on your own. Okay, and the final answer is given in the slide. Okay, check. Okay, now I want you to look at this one. Okay, so the yellow color is tangent. The green is normal, and the blue is binormal. Okay, so you see when it because this one is keep moving to the left hand side, right? If you look at this as the moving direction, it's keep turning to the left. Okay, so that means the torsion it will always be positive, right? Okay, now you see when this is moving, this is also showing what is the curvature in green. This is curvature. This is the one in blue is torsion. Okay, so the torsion. Okay, you see there is a later part where it moves. Okay, it turns to right a little bit. Okay, but you see when this point it turns to the left. This it moves a little bit to the right, okay, then it moves back to the left. So when you see this spike, okay, this one, when it spike, see the binormal, okay, the binormal vector, it somehow like it flip out to the opposite direction of the normal vector. Okay. Okay, I think I used the wrong sentence just now. This one, torsion, it refers to the flip of the rotation of the oscillating plane. Okay, so the plane that's planned by this yellow and green is the oscillating plane. So when this plane, you see, it swing out, right? At this moment, it swing out. So when it swing out, the torsion is spike. Okay, the torsion suddenly spike. Okay, because it moves, it rotates to the right hand side, not right hand side. How to say? It rotates to the direction which is opposite to the normal vector. Okay. So suppose a particle moves in this way, okay, and when this oscillating plane it suddenly rotates to the right, the torsion spike. Okay, because this is positive torsion, this is negative torsion. Okay, so when you see a little bit, this one, it somehow it flip inner side to the direction of the normal vector, right? So it the value of torsion is negative, and suddenly when it spike, that means it flip out to the direction which is opposite to the normal vector. Okay, that is torsion. And you see the curvature, the green, the one green in color. Okay, when it moves down, what is the point when it moves down? Here. Okay. Down. Okay. Let's see the curvature. Curvature. When it reduces, what it means? When the curvature reduces means curvature reduce means the circle is being larger. The circle is larger. Okay, for example, this one, when it turns, okay, when it turns and suddenly it goes flat a little bit, at this point, the circle is larger. At this point, the circle is smaller. So that means it how to say, when the curvature value drop, that means it goes to the, it turn this tangent vector, it turn in the slower rate. Okay, so you see this tangent vector, when it turns faster, the spin curvature is higher. But when it moves, when it slowly turns, okay, that is curvature lower curvature. But as it moves, it changes the direction of the tangent vector faster, that means curvature is faster. Okay, so when you see these 3 points, this point, and it, okay, that means here this one is more like flatter compared to this point, right? This curvature is higher. This curvature is lower. This one is lower. This one is higher a little bit. That is curvature. Okay. That means how fast is the tangent vector change? We look at the curvature. And how fast is and what's the direction of the binormal vector? Whether it turn to into the direction of normal vector or turn out, and how much it turn out is torsion. Okay, that is torsion. Okay. Any questions? This is space curve. This particle moves in space curve. That's why the curvature it is always positive. Okay, not positive, non-negative. Okay, non-negative. Okay, so that's all from this course. Okay, so I will see you again during your final exam. So before this, if you have any questions, you can post in the group, okay, or you can personal message me. So if there are any questions that work to be discussed together, then I will repost into the group. Okay, so try to do some research based on the final question, final here, the past year question. You know how to find the past year paper, right? From the library website. Okay, from the library website. Okay, so good luck to all of you.